HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 103, recorded live Wednesday, March 5th, 2008. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. Support is also provided by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott talks with Quetzal Bradley, a Microsoft developer on the Connected Systems Architecture team, about testing after unit tests.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm sitting here in Building 42 on the Microsoft campus, and I'm sitting down with Quetzal Bradley, a developer on the Connected Systems Architecture team.
Hello.
Thanks for taking the time. I was given your name by Chris Sells, who just raved about some of the stuff that you were doing internally and said that you gave a presentation on testing after unit tests, and I saw this and immediately said, okay, I've got to come and hang out with this guy. So now that I'm up visiting in Redmond, I'm happy to be able to sit down and chat with you. Now, I've worked on systems that have done testing and unit testing and code coverage, so I thought I pretty much had a handle on that, but you've got some ideas that indicate that maybe I'm not as prepared as I thought I was.
Well, yes, I guess most people are familiar with unit testing, and a common metric when you are writing unit tests to know that you have sufficient tests is code coverage. Mm-hmm. And so oftentimes the goal will be 80% code coverage. That says that your tests hit 80% of the lines of code, essentially, mm-hmm. In your product. And ideally, of course, you would hope to get 100%. But if you have 100% code coverage, does this mean that you're done testing? You can ship your product to your customers, and your customers will be delighted? And I think the answer typically is no. So then the question becomes, when are you done testing? And how much testing do you need to do? And how do you know what tests you should do and whether they're sufficient?
So if I had a method that, took a Boolean and I have an if statement inside it, if this, else that, I've got two branches, and I might run a complexity analysis and do a cyclomatic complexity, and it would tell me that there's two ways to get through that method. I'd then maybe write two tests. I'd say that I had 100% code coverage, and I'm feeling at this point pretty good about my code.
Right, but maybe you shouldn't be. One of the things is that code coverage can't measure the coverage of code that's not there. And so, for example, your function may be missing error checking. If you pass a null parameter to there, and that is dereferenced, you're going to get a crash. Your 100% code coverage won't detect that kind of condition. Even if you do have all of your error checking and all the code is in fact present, and you still have 100% code coverage, the data itself is what is going to determine the behavior of the function. And that isn't measured by code coverage. But code coverage does tell you something really important. Code coverage tells you what code you have not tested. It's a negative metric, but we tend to think of it as a positive metric. So if you have code coverage, it tells you that it's possible for that code to execute correctly, at least in your test. Mm-hmm. But it doesn't mean it's going to work correctly for a customer. On the other hand, if there's a bit of code that it has no code coverage, you know that you haven't tested it, and so you know that you don't know whether it works or not.
Okay, so I to say this again to make sure that this got, because I'm drilling this into my own brain at the same time as we're drilling it into the listeners.
Yes.
By doing code coverage,
yes,
I determined that it is possible for that code that I've covered to run properly.
It's possible.
It's not that it ran properly in this instance.
Right.
But there is other parallel universes that it very, very likely will not work.
Well, yeah, I think I can give another example, maybe an analogy that would make it easier to understand, and which is, suppose that you are going to test the road system in the state. Right? And so, you know about all the roads. There's little roads, there's driveways, there's freeways, there's highways, and you take your little, 3-cylinder hatchback and you drive it down every single road.
Take a small car,
yes,
drive everywhere.
Absolutely. And you may find that, you're successful, or maybe you run into a power line over the road and you need to remove that, or maybe there's a bridge that hasn't been built yet. So you discover those things, you fix them, you've got 100% road coverage, mm-hmm, and you feel pretty satisfied. Then you, say you open up the roads and you let, people go and drive on them. And maybe the first thing that happens is that a double-decker bus gets onto the freeway and runs into an overpass, crashes into it. And so I think that it wasn't really sufficient to test every road. You also needed to know what kind of vehicles were going to be traveling on them. Maybe your 3-cylinder vehicle was always going slow, and when an 8-cylinder Jaguar turns the corner, it goes flying off the road because it's going 100 miles an hour, and the speed limit sign was 120, maybe even. So if we wanted to test the highway system very effectively, it may be that we do want to send a slow car and a small vehicle down every single road to find the roads that aren't finished, etc. Mm-hmm. But the way to get the most effective results would be to take a large variety of vehicles with different capabilities and sizes and shapes and speeds and perhaps drivers and send them down every road. But the problem then is it may be that we don't have the time or the resources to send so many vehicles down every single road in the state. You could imagine that might even take years to complete. So we need to prioritize, right?
And this is about mapping requirements to testing.
Absolutely. So not every road is equally important, so if the freeway is used by much more people than my driveway. And so a flaw in my driveway is going to inconvenience me and my immediate neighbors. A flaw in the freeway is, cripple the transportation system for the entire state. And a similar thing comes up in software, although we might not think about it. I had this experience with a piece of code that I was writing some tests for. I didn't have any tests yet. So I had 0% code coverage, and I wrote one test case. Not even a test, but just a test case. And then I measured the code coverage, and I had 37% or something like that. And I was pretty pleased. That's a lot of code coverage from one single test, right?
Okay. Was this a small bit of code?
No, it wasn't that bit. So it was a driver, actually.
Okay. So you went through a lot. You bounced around inside that driver for quite a while by that one test case.
Absolutely. I sent an IO request to a driver, and it was handled by the entry point, and then it was passed to another function, and another function. It was so the error checking was invoked, and et cetera, and it went all the way down to the bottom, and then came back up. So it actually hit quite a bit of code. And so I then wrote a second test case. In the second test case, now my code coverage is like 45%. It's like, great. A third test case, my code coverage was like 50%. Okay. A fourth test case, it was 51%.
Kind of asymptotically approaching.
Exactly. And then 51.5%. And then, so getting to 50% was incredibly easy, but getting to 70% is very hard. But the part that really surprised me is that I ran my second test case by itself, measured the code coverage, and it was about 37 or 38%.
Interesting.
In other words, every test case was hitting a whole bunch of the code, exactly the same code every time.
Right.
And then there was a little bit of sort of the side paths.
So you've got a lot of, I'm imagining this Venn diagram of all the code that you're covering, and I'm seeing huge chunks of intersection.
Yes.
And then you're getting little bits that are specific to a test case that are letting you get that extra % or two.
Sure. I think I'd go back to the highway analogy, and there's part of your code that's like the freeway. And if you're going to go anywhere, you pretty much have to get on the freeway, get close to your destination, then you get off and go on some side roads. If you have a different destination, say a different test case, you're still going to get on the freeway and drive down all that freeway road, but then you'll take a different exit and there'll be a little bit that is different.
Right.
And so that freeway is the easiest code to hit, but it's also the most important code because any flaw there is going to be impactful to your customers. There's some little corner of the code that takes a real special test case to get to it. It may be that very few people will be impacted by flaws there. So even if you do miss it, it's going to have the least cost. And so if you have a set amount of time in order to do your testing, now absolutely you would like to have breadth coverage, which is make sure that all the parts of your code can function. But when you're putting the extra effort in, you would want to have a more diversity of data and more scenarios around that highway, which is the most impactful, right?
So how do you figure that out? I mean, is that about using a profiler and then spending time seeing where we're heading through, or basically running a test case with coverage and using coverage not as a number to make you feel better about your testing, but rather as a number to know where in your code you're exploring?
Yeah, you can use the coverage to know in terms of breadth what parts of the code you haven't touched yet. But it doesn't give you any information about depth. Now, about knowing where that highway is, well, the answer is however your customers are going to use the code, that's the important code. And that's the important paths. So this is where it does come back to requirements. And so it is a little bit harder because sometimes people use the code in ways that we don't necessarily anticipate. But to the degree that we can emulate the customers when we're testing, that's where we can go beyond unit testing and create tests that are going to be more effective. So, for example, I've worked on a lot of frameworks, and with frameworks, customers are developers. The developer is going to write a program. He's going to use the framework. An excellent way to test this is to create a sample. A sample is the process of writing a program exactly like the customer is going to do it. And you'll run into issues like usability or awkwardness or discoverability. So that's kind of nice. But in addition, when your sample is done, you should execute it as part of your test passes, because any flaws that are uncovered as a result of running the sample are very likely to be exactly the flaws that the customers are likely to run in first. In other words, those most serious day one kind of bugs.
And it seems obvious that if you're writing a framework, you need to use it. And I've written frameworks before, and I've worked at companies where we've written frameworks, and some of the early versions where basically things went horribly wrong were when we didn't come at it from the outside in. We didn't put ourselves in the shoes of the developer who would be using it. So we didn't write samples, and more importantly, our test cases didn't look like samples. They didn't reflect the reality of the use of that framework. So I can definitely relate to having code coverage numbers that look right, but in reality, I wasn't protected.
Yes. And so again, the unit tests don't look like samples, but they're important for the purpose because they give you that breadth. To get to 80% code coverage just with samples would be really difficult because, again, like each additional sample, which is costly, is going to give you an additional 0.1% maybe. So you have your unit test for the breadth. Then you create samples for the depth. And the samples aren't going to go on every byway. They're going to be going down that main highway of the code.
Right.
Now, if you're not creating a framework, there's still approaches that you can take. And the general and mentality is around the same code I'm executing over and over again with variations, of course, but mostly the same code. But it's the diversity of data. That's what customers bring to software that we don't have when we're executing it on our developer machines. Is they have their own data. It's bigger, it's stranger, it's less consistent. They create it in ways we didn't anticipate. Their environments aren't exactly the same. Our developer machines can be top notch. Maybe they are short on memory. And RAM on their computer, and that can have an impact. So it's all those differences that make it likely they'll run into issues that we don't know about in advance. So to create a really interesting test, maybe it's a very simple test, but maybe it has a huge variety of data. Right? And you can put into it. You can write tests that generate data on the fly, or maybe you have a pile of it lying around.
So it seems like when I'm thinking about terms of generating data, there's generating data from the customer.
Yes.
Where you can basically make your application phone home, kind of the Windows error recovery, Dr. Watson way of doing things. I mean, that's free data. If someone's going to hit send information, that's good stuff. We can use that.
Absolutely, you should use that. And certainly, if you have such data, you should use it to find out what is the kind of problems that are occurring and find out why your testing isn't discovering that. And that'll inform about what kind of test you need that you might not have. And, well, one way to get data for putting into your test cases is, depending on your relationship with your customers, is maybe they can give it to you. If they have a share full of input, of files have accumulated, take that and use that. That's going to be the best kind of data you could have because it really is from customers.
Now, you had given an example to me while we were walking the hall earlier about a situation where you had some faults that had occurred in some software that you'd been involved in that was indicating there was a problem. Basically, something went wrong and something phoned home.
Right.
So you went to the code to find out what was going on.
Right. Well, and this was an investigation of, just like I said, an investigation of what kind of flaws were being discovered by customers impacting them that we didn't discover in testing. This particular component was not well tested internally. It had 50% code coverage, which doesn't mean it was 50% tested. It means it was 50% untested. So we would expect that the problems would be lurking in that untested code. And I mean, isn't that what you would expect?
Well, that was the thing that you said earlier that really has changed my perspective, is that code coverage is an inverse number. It's something that I want to say. I know well, actually, it's funny. There was a movie with Hugh Grant, where they had a baby, and it was an unexpected baby. And he said, well, I don't know what happened. The protection I was using was 99% effective. And the answer was, well, that makes it 1% completely ineffective.
Right, exactly. Yes. Well, personally, I expected to find the flaws in the uncovered code because we hadn't tested it at all internally, at least not formally with the formal unit tests that got measured by code coverage. So, in actual fact, of the three parts of the code that were being hit by customers with crashes causing a serious problem, all three of them were in the covered code, in the covered blocks. And so now I think I have an understanding about why that would be. That 50% that was covered by tests was the highway. It was the highway through the code that everybody hits. Naturally, that's where the flaws were found that were hit by customers. It may very well be that there were flaws in the uncovered code that we didn't cover in testing. And as it turns out, that's the same code that the customers weren't running. And so they weren't discovering those flaws.
What kind of metrics can I apply? I mean, it sounds like you've shaken my confidence in code coverage as a number that I can use for confidence. I mean, now it's just code coverage has become just another data point that I can use. But I feel like I need another dimension.
Yes. Well, in a perfect world, you would use state coverage. And state coverage is all the states that my software can be in. Unfortunately, state coverage is typically infinite. But please don't despair because...
I'm sorry, it's too late. I've already begun to despair.
Sorry about that. Not all the states are equally important, right? So the states that the customers are going to get the software into are the most important ones. I think that there are efforts maybe in research and other places where people are trying to tackle this problem. But practically speaking, in everyday to day life here, we have to do something more practical. And what that really comes down to is getting feedback and iteration. So once you have your high unit tests coverage and your code coverage is high, so you know that there's not much code that you're never looking at all. That's a good starting point. Then you want to do samples or customer-oriented testing, stress testing, especially with the functional testing, a diversity of data that's likely to cover the things you haven't even thought about with data generators or data from customers or approaches like that. Once you've done that, you should think to yourself, well, at least I've covered the basics now. If there's some hope that this is pretty good quality, that's where you need feedback. And the feedback is get people to try it, is looking at what is your bug find rate from your internal deployment or from manual testing. One of the things that can be very effective is directed ad hoc testing, where you take people and you say, here's an area to look at. Just try it out as if you were a customer and see what kinds of things you run into. And a lot of times that will uncover things that your test automation just never even thinks about.
We had a podcast a couple of episodes ago where we spoke with Peli Delu from Microsoft Research and his PEX project, which uses kind of some mathematical modeling to look at a method and say, here is the domain in which I want to explore. So it takes code coverage almost like chess. You put your finger on the chess piece and there's so many moves that you could make. And humans can only make so many moves, but a computer can go farther and farther and farther down the decision tree. And, hopefully we'll see something like that soon from Microsoft Research. But, it's more of a brute force way of trying to stumble on these kinds of issues where understanding more of the behavior-driven aspects of things, like behavior-driven design would be a better way to find these highways.
Yes, that's very interesting. And there's two big kind of approaches you can take there. Essentially, this is forms of model-based testing. And so I believe with PEX, from what I understand, it looks at your code and infers usage patterns from the code in order to drive test cases through it. And that's very interesting. It does suffer from the flaw, again, that if the code itself is missing functionality or is wrong, its inferences will be based on what has been written rather than what was intended.
Right.
So that leads, still could be a very valuable way of getting effective code coverage for your breadth testing, I believe, and other potential as well, especially as we can add more metadata about our intentions that a tool like that could use. Another approach is where you have your code, but you create a model completely separately, which is based on my way of saying, this is what I intended. Now, obviously, the model has to be simpler than the code itself. Right. Otherwise, you've just written the program twice, right? Once in a modeling language and once in the actual implementation. So, and I have seen this happen where people have gone to the lengths of trying to create a model which completely represented their entire functionality of their software, and that tends to not be very successful. But where I have seen tremendous success with model-based testing is creating a model that's very simple because it's only focusing on one aspect of the functionality that's expected. And so, for example, in a framework, maybe the object lifetime of your framework objects. If you have a complicated rules around when they can be destroyed, when they can be cleaned up, and the relationship between parent and child objects, you can create a model just around that and get a lot of value without trying to create something so complicated that you can't even understand the results of what it's creating. The thing that models give you, which are really great, is they give you a test oracle. A test oracle is the code that knows when a test runs whether it's right or wrong, the result that you got. That's actually the hardest part of creating any kind of test. Writing code to execute into your software, pretty straightforward.
Right.
But then, did the test pass or fail? In the simplest naive case, you say, well, it didn't throw any exceptions. It must have been correct.
What is my assertion?
Yes, exactly.
One of the things that a boss of mine really drove into my head at my last job was he said, if the system gets, and we're speaking about .NET code here, if the system gets into a state that it shouldn't be, this is not the time to be throwing an exception. He says, debug.assert. He says, stop. Panic, freak out. He says debug.assert is as like the most underused thing he could think of in the framework, because there's exceptional cases, a time when data coming in should throw an exception, and you should handle that gracefully. But if there is a state that the system can get in that it has absolutely no business getting into, like this should never happen, you know it, I know it, the guy who's working with you on the program knows it, but if you don't say it to the code, debug.assert, X is null. If X is never supposed to be null, then do that. And it says nothing will make someone fix a bug like a big debug assert in the middle of the running of an application.
Well, that's a fact. Absolutely.
Now, it's interesting. It seems to me, I'm trying to put this in the context of maybe a smaller ISV, or maybe some of our listeners may have small kind of 2-pizza teams.
Sure.
Smaller teams. I like to say 2-pizza teams. That's what Amazon says. The size of a project should always be the number of people that you could feed comfortably with 2 pizzas.
Sounds reasonable.
Anything bigger, it's unruly. That the best way for a smaller organization to get this data is to instrument their code to phone home, to, quote unquote phone home, like a tool like Smart Assembly. Microsoft has Dr. Watson. Can I make my code instrumented with Watson?
Can you make your code instrumented with Watson? I'm not 100% sure on that myself. I do know that it is possible from Microsoft to get that data on your products.
So if you're blowing up majorly and
Yes.
you hit send information, that's being held out there. I'll have to dig those people down and find out how I can find out if my applications are sending those. But I'm always impressed with applications. And Smart Assembly is the product that comes to mind, which is an aspect-oriented thing that weaves into your assembly after the fact, and when an exception occurs, we'll phone home and speak to we'll speak to an endpoint.
I think that's an excellent idea, because despite our best efforts, it may be that where we thought the highway was and where it actually is aren't the same. And phoning home is the way that we're going to be able to discover that.
Because ultimately, what happens in reality, no matter how lofty your ideas were, no matter how much planning and putting into the model, you may think they use it this way, but the fact is they do use it that way.
Right, exactly. I guess one other thing I would want to say is that these days there's a lot of focus and effort on automated testing and automation. Mm-hmm. And the thing that I really notice about that is that it's really a trade-off, and it's not always the right thing to automate all of your tests. Because what happens if you focus on 100% test automation mm-hmm. is you just don't write the tests that are too hard to automate. And then very important things don't get covered. This is the reality of what happens. So an example of things that are extremely hard to automate are, what does your test measure when it's running? If your product has a user interface and the user interacts with it, maybe you use UI automation to press some buttons. Of course, that's a high cost to maintain kind of test to mm-hmm. write it and also to keep it working as the UI changes. But let's say you've done that. What the test doesn't know is it doesn't see that the color is strange, or that the screen flickers, or maybe you have timing to make sure that when you click the button, something reasonable happens within 30 seconds, but maybe the fact that it's taking 1 second to the user makes the application feel like it's sluggish. So that is flaws in those kind of automation that make their value less. Not zero value,
Sure.
but just less, and the cost high because of the continual changing you have to do. On the other hand, especially when the UI is under frequent change, suppose you have a manual test. Well, the problem is boring to do manual testing. Well, for a lot of people, it's boring, but there are people actually who do enjoy that, and so it would be interesting to find some of them and see if they would like to help you out. But in any case, if you're going to do this yourself, you're a two-piece team, you're not going to pick someone else up. You don't have to do it a lot. If everybody sat down for 30 minutes at the end of the week and went through it, that would be quite satisfactory to catch these kind of issues, most likely.
You know, for applications that have a user interface, one of the neat ideas that I saw when Office 2007 was being worked on was this little smiley face that would sit on the dialog box. It was a happy face and a sad face.
Okay.
And if you saw something that you liked, you clicked the happy face, and it would take a screenshot and allow you to annotate it and then send it directly to the team. And we actually wrote a little thing up, and a number of people made libraries for WinForms that you can just add in. And then while you're in your testing phase, someone can go at any point at any dialogue and say, I like this, or I don't like this. And it'll do a screenshot. And then you get all this fantastic data going directly into your bug database with pictures of real people's screens doing whatever it was or was not supposed to do. And you get both negative and positive feedback. And because it's presented in such a pleasant way, just simply a button in the title bar with a happy face or a sad face, everyone understood it, and everyone's excited to give that feedback. And that's another way to collect data that I'm starting to realize is more and more important.
Absolutely. I think that's a really interesting idea. Now, suppose you've clicked that frowny face a few times and some others, and so in development, the product now has changed, and that interface changes. If you're using a low-cost script with manual testing to keep that area covered, when a human comes to that and sees the difference, they're not going to fall over and say, test pass failed, go spend half an hour investigating to try and find out why this test case failed and then fix it. They'll just go right past. That's where the efficiency comes from. Now, of course, once you've shipped and you're in maintenance mode, it may make a lot of sense to do UI automation in order to catch regressions, especially because you're not going to look at it frequently and when the occasional bug fix comes in. So the point there is that automation is not a panacea. You should try and make that trade-off. Is the time that I invest in creating this automation, don't forget to count the maintenance cost, going to give me a return versus the doing the manual testing at this point in my project versus another project. So I'm very happy about all the automation people are doing, but sometimes I worry that people get carried away too far.
Yeah. When I think, and you bring up a really important point about regression testing, one just can't remind oneself too much about how important it is when a bug comes in to write a test that causes that bug to happen and then watch it fail.
Absolutely.
And say, I understand why this bug happened, and then to fix it. That red-green unit testing is important, but it's so much more important within the context of regression. Because there have been a million times where I've fixed something, thought it was great, but just didn't back it up. Again, this is the notion of making an assertion in your head versus backing it up with an assertion in the code. It's so important.
Absolutely.
Well, I really appreciate you taking the time to sit down with me today. And this has been really interesting. And this has been another episode of Hansel Minutes. We'll see you again next week.